Correlational research design. There are a lot to talk about correlation research design, but I will focus my discussion on a few, like what are correlational research designs and why are they used in behavioral research or in research? What patterns of association can occur between two quantitative variables? What is the Pearson product moment correlation coefficient, or what is R? What are its uses and limitations? How does the chi-square statistics assess association for categorical data? What is multiple regression, and what are its uses in correlational research design? How can correlational data be used to make inferences about the causal relationships among measured variables? What are the limitations of correlational designs in doing so? What are the best uses for correlational design? So, statistical assessments of relationship is really the concern of correlation. When the research is interested in identifying differences, we end up using causal comparative instead of correlation. But when we use correlation, then we need to ask whether the data we will arrive at is quantitative or categorical or nominal. If the data is quantitative and you have more than two predictor variables, you end up with regression analysis. Most of the time, you compare relationships of only at least two. In that sense, you have a correlational analysis or an R. If you have two categorical or nominal data, you end up with chi-square analysis. And when you do three or more categorical data, you end up with the log linear analysis or the logistic regression analysis. The most common of all, of course, is the Pearson product moment correlation or the correlation coefficient. In this sense, you realize you're comparing two groups, in this case, the college GPA and the high school GPA. And in plotting the lines, you see how the two are related. This is called the scatter plot. And more or less, there's a regression line that is formed when all the dots had been laid down. So a graph in which the x-axis indicates the scores on the predictor variable and the y-axis represents the scores on the outcome variable, a point is plotted for each individuals at the intersection of their scores. By the way, these PowerPoint slides comes from the University of Michigan. A regression line is formed when a line is squared distances of the points from the line are minimized. So that's the regression line in the scatter plot. So the linear relationship and the non-linear relationship are very important in the identification of interpretation of data. When it's going towards X, as you can see, that's positively linear. If not, that's negatively linear. But there are more instances, for example, where the dots is curvilinear, that it follows a U shape. There are dots where it is also inverted. That's the another curvilinear manifestation. And lastly, when the dots are independent, which means there's no relationship between the X and Y that is discernible. So the Pearson product moment correlation follows this formula. Of course, with it's very important that you should be aware how the two should be computed. That is actually left as a task to your statistician or better yet, to your statistics class. With the advancement of the statistical software or package for the social sciences, we actually do not already encourage the putting of formulas in papers, as these are technically Googleable. Now, how do we interpret R? If the relationship between X and Y are positive, then we look at R as having a positive, the R should be uh, less than 1 but greater than 0. If the relationship between X and Y are negative, then the R should be not greater than 0 and not more than -1. 1 is the perfect score, in fact. -1. So 1 is a perfect score for positive correlation. -1 is the perfect score for negative correlation. So if the p-value associated with R is less than 0.05, then the variable X and Y are actually significantly correlate to each other. That's what it means. No, significantly correlated. So if p-value is associated with greater than 0.05, then there's no significant correlation between X and Y. So normally, this is how we report correlations. As predicted by the research hypothesis, the variable of optimism and reported health behavior were significantly positively correlated in the sample blank. In reality, and it's worth saying now, a preset criteria for interpreting correlations must be made, specially and put in the treatment of data section of a thesis. Now, the preset criteria, it needs to be said, can be Googled, in fact. So, that's how it's done. Okay? So, cases, of course, there are limitations to the correlations. For example, when cases in which the correlation between X and Y that have curvilinear relationship will provide a score R that is 0. Cases in which the range of variables is also restricted is also very important. Or cases in which the data have outliers, in that sense, scattered scores, and therefore, because of that, that too is the limitation of the research. So these are examples for curvilinear, for small range, when we have very limited data where they actually merge with each other, and the outlier, that's in the pink one here, which is the maverick, the one that is out of normal reading. Chi-square is normally used for categorical data, and this is how it looks like. Again, the formula, you need not take note. But to interpret chi-square, this is how it's done. We look at it in terms of degrees of freedom, the number of participants, and whether the alpha is less than 0.05. So if chi-square is greater than the value in table E, the contingency table is significantly different from the expectation, something like that. So when you report chi-square, this is how it's done. As predicted by the research hypothesis, the Southerners were more likely to approve of a policeman striking an adult male citizen who was being questioned as a suspect in a murder case. And this is how you report it. The correlation, of course, I hope you'd utilize more of the Pearson product moment correlation, but I'll leave that to your statistics class to explain. Again, if you like this type of video, please subscribe, click, and share the channel Samo't sa Simula. Thank you very much.